Okay, I guess we'll get started. It's my pleasure to introduce to you today Patrick Drohan. Patrick's an assistant professor in Penn State's Department of Ecosystem Science and Management. We had a great conversation with Pat today. He has an interesting academic background that combines forestry, fisheries, and soil science. He's been at Penn State as a faculty member for about 6 years. He's taught in a number of courses in natural and physical sciences there. Most recently, he's focusing on courses in soil classification, soil genesis, and urban soils. Patrick's research has both basic science and applied elements. Generally speaking, he examines people's use of landscapes and the accompanying changes in soil function across the larger ecosystem that the soil supports. Pat has a really comprehensive understanding of shale gas issues, especially as they relate to the Marcellus Shale in Pennsylvania. One of his current projects involves assessing landscape change due to shale gas drilling and devising remediation strategies to minimize site impacts. And this is the topic that Pat's going to present on today. So Pat, when you're ready.
Thank you very much, Jim. It's a pleasure to be here at Yale today. First, I'm standing here before you because of a lot of other people. And those are colleagues of mine like Dave Mortensen, Margaret Brittingham, Joe Bishop, Doug Miller, Brian Bills, Paul Roth, and several agencies that we've worked with. Our funding has largely come through Penn State's Marcellus Center, the Heinz Foundation in Pittsburgh, the U.S. Department of Agriculture, and the Pennsylvania Bureau of Forestry, Department of Conservation and Natural Resources. And we would not be able to share the story today that I'm going to share with you without that support and those individuals. And most recently, we've had some in-kind support with data sharing from Seneca Resources, which we greatly appreciate. The issue I'm going to talk about today with shale gas development, or what we call unconventional gas development, is an issue that's not only affecting the United States now, but also the world to a great extent. And in this image, you can see the variety of sources for shale gas to be extracted in the United States. The issue I'm going to speak about today is specific to the Appalachians as a whole, and will thus affect areas stretching from New York State down into Kentucky through West Virginia, Maryland, and Pennsylvania. For those of you who aren't familiar with unconventional gas development, the largest difference with conventional gas development is the way the drilling and the depth of the drilling occurs. And this schematic, which you probably can't read, basically shows a multiple casing system going all the way down to 5,000 feet, which is then turned via a lateral line horizontally. When shale gas development was first started, the bulk of it was vertical drilling, such as was done in Texas. What changed was the horizontal drilling. That was the technological achievement that made the ability to move to larger distances away from that pad at the top of the location feasible for economic extraction, coupled with the ability to exploit that formation at depth via the hydraulic fracturing process. I'm not going to go into a lot of that today. That's a topic outside of my realm, and there's plenty of information on the web about it. But the point to make is the area that's most affected from the standpoint that I deal with personally is right up here at the very top. And that's the area that most people who deal with this issue as a landowner basis are thinking about. And that's important to recognize because there's a significant disconnect in thinking between what an industry is typically worried about, which is this, versus what the homeowners are worried about, or the land managers are worried about, which is this, or that aquifer where that drinking water is available. When that vertical and horizontal well is going into production, you have a lot of activity on an area very large. And this is one of the other most important factors to take away from this lecture today, is the extent of the change on the landscape is one of the most important things that we've recognized is occurring in Pennsylvania compared to traditional drilling or to conventional drilling. You're looking at an area in size of about 5 acres. This could have been virgin forest 3 weeks prior. Once the drilling process is underway, you literally have, as Jim Rickendorfer from the SRBC, Susquehanna River Basin, says, an orchestra of activity occurring on the pad. And it really is an orchestra activity in the sense that you have numerous people involved on this pad and even all the way down in Houston, Texas, controlling the drilling operation and monitoring the drilling as it's occurring. It's a pretty incredible technological feat what they can do. At the end of the day, you have at the surface the one pad with numerous horizontal lines going out. And it's these horizontal lines that are then pulling the gas, once that shale's been fractured, back to the surface to then a feeder line or a transmission line which moves that gas from the pad to a larger continental federal line, as we call them. What I'll be speaking about today are the terrestrial challenges facing shale gas development in the Appalachians. And in Pennsylvania, from the standpoint of landscape management, the two biggest limitations we're dealing with first involve soil limitations. The Appalachians don't have the history they have because it's easy to farm them. If it was, you'd have an incredibly different economy. Appalachia is what it is today because of its soil. And that soil is some of the hardest in the world to manage. It's wet, it's rocky, it's shallow to bedrock, it's got a lot of relief, there's a lot of steep slopes, and you have a subsurface restrictive layer at about a half a meter in many places called a Fragmentation. This is a subsoil horizon which can perch water and turn roots. Because of these soil limitations, Appalachia has largely faced a resource extraction economy from timber to oil to gas. And it will likely always face a resource extraction economy unless some other way is found to manage that land and make it productive economically. Once that pad site is cleared, there's a couple of options that can be done. But one of the things that we were first curious about when we were looking at this issue was what are the characteristics of the sites where the landscapes are being developed. About half of the sites we're finding are fairly rough sites, which are reflected across generally across Appalachia. A small percentage of them were formerly disturbed areas. A quarter of them are rocky, steep, or low fertility sites. 1% to 2% tend to be very sandy sites, which is usually confined to just a couple of the geologic formations in Pennsylvania. And about 15% of them have that subsurface horizon that can restrict water movement. So about half would be fairly challenging soils to use to begin with. And this is important to think about because if we're going to be thinking down the road about reclamation, what would be the ideal soil condition we're starting with, right? Now, if we look at the better sites, all right, we're starting to find sites that might have more moisture, but in this case, they have too much moisture. So almost a quarter of the sites have some type of water table problem. That's either a shallow regional water table or a perched water table condition. So these are sites that, if they're developed, could pose a problem on the landscape from a hydrologic perspective, or in reclamation could pose a significant challenge in how we reconstruct that functional soil hydrologic system. At the end of the day, you've got about 32% of the soils that are being developed that are pretty good Appalachian soils for reclamation. They might have low fertility, but they don't have significant challenges because of drainage or rockiness. And about 18% are good soils. You might need a little bit of an amendment when you're reclamating that site, or you might have to do some extra bulk density remediation, obviously, if you have significant compaction. But about 18% of those soils are pretty good. So the point to take home from this message here is a lot of the soils, at the end of the day, after they've been significantly disturbed, are still going to be pretty challenging soils to deal with from a reclamation perspective. After the soil challenge in Pennsylvania, the second largest challenge facing development in Pennsylvania is the relief. And here we have Bradford County and a transect stretching across Bradford County from the northwest to the southeast here. And this is just to give you an example of the extent of the relief across that area. The most common comment we heard from the gas companies from Texas when they arrived in Pennsylvania was, wow, this place is hilly and it's wet. And that's hard to deal with if you're not used to it. And they had some significant problems early on in learning how to deal with these landscapes and the seasonal changes in moisture that occurred on these landscapes. This becomes a problem because once these landscapes with high relief experience some moisture, soil materials, once loosened, start to move around. And once they're moving around, they can end up in water bodies as sedimentation and cause problems in those adjacent streams. So we were curious about the sites being developed, where they were occurring on a hill slope position, and whether that hill slope position had a tendency to converge moisture and become wetter, or tended to shed water to begin with. All right? So starting out, what we find is about 66 to, well, almost 90% of the sites are on these back slope, hill slope positions, and of those, about 30% are in these landscape positions that could receive moisture. All right? That doesn't mean they have a water table problem, but they have a high potential for a water table problem because they're converging moisture in that landscape position. If we then look at the risk on these steep slopes to surface water movement and what BMPs are being implemented, what best management practices are being implemented on some of these high-risk landscapes, we're starting now to look at the potential for erosion and sediment control problems that the BMPs might not be addressing. Pennsylvania's stormwater management was never designed to handle a situation like this. This is a gas line developed across part of an area near Waterville, Pennsylvania. You literally have over 200 meters of landscape cleared about 45 feet wide across a slope greater than 25%. And this was barren from November to April. This is basic soil mechanics, basic agronomy. You don't have to be a scientist to know this isn't a good thing to have bare for that long of the year. And this is an exception to the norm. We don't see a lot of this, but the fact we see some of this is what keeps me awake at night when a large storm system like Hurricane Sandy or Tropical Storm Ivan is coming up the coast. Because if one of these lets loose, that's when you have a significant landslide risk. Once reclaimed, this is what it's going to look like. That's the same site in midsummer. Okay, so still a significant slope. Functionally, that's going to be a different landscape. Does that matter? A lot of what we were doing early on when we were first exploring the issue of shale gas development was documenting the problem. You found a new disease, you document its characteristics. Then you start looking at the basic science questions. How is this different from what we know has occurred before in other types of disturbances? If we start to look at those slopes where development has occurred in Pennsylvania, we find that most of the areas being developed for pads are not on steep slopes. A small percentage of them are, 10%. Those are ones to pay attention to because if you're cutting a pad, a flat pad into a hill slope, you're going to have what's called a high wall, which is what you see in a strip mine. So you've got this big chunk of bedrock and soil sticking up, which you have to stabilize or it could slump over. Right? And when you reclaim that area back in, you've got to reproduce that original contour, move all that material back. You know if you dig a hole and put the soil back, what happens? Not all the soil fits in the hole because you've added more porosity. So now you got to deal with slumping unless you achieve an adequate compaction with your soil mechanics. So 10% of the sites are going to be ones we're going to really want to watch. But overall, where the pads are going is not the problem. They're mostly going on flat landscape positions. It's the pipelines and the roads that you're going to see that are the potential problem. If you look at Pennsylvania soils as a whole and you start to look at a parameter in the NRCS soil database called runoff class, you can use this as a way to look at one of the worst case conditions a soil might face. If we look at runoff class in relation to slope, there isn't always a direct relationship. You can have a worse runoff class and be on a shallower slope because when you're looking at the runoff class, you're looking at a saturated soil that's bare. It's a worst case scenario. And this is what starts to make us nervous now because we're realizing that we have 70% or more of our soils that are medium or worse runoff class. And this is a typical type of condition if that site is being developed. There's no vegetation, it's compacted. It's very easy to saturate up the little soil that's there that had a porosity to begin with. So now we start seeing that even though we may be on these gentle sloping areas, we have a problem we have to worry about. Pennsylvania Bureau of Geology has developed a landslide risk map. In this case, the redder areas have a higher landslide risk. If you look at the distribution of where the gas is being developed in Pennsylvania, you see a fairly large chunk is in these areas prone to landslide risk. So you start adding the story together with the slope problems, the surface runoff. You start to see there's some potential in some areas for some significant challenges for landslides in these areas that are being developed in the southwestern part of the state. In this part of the state, you still have an area you need to pay attention to. It has a lower risk, but because we're developing those slopes that might have those pipelines going up them, now we've got areas we need to focus on for monitoring more. And we know these are not uncommon. These tropical storms are not uncommon anymore in the mid-Atlantic. We're seeing in Pennsylvania higher frequencies of higher precipitation events, period. It doesn't have to be a tropical storm. Last summer was absolutely bizarre with the intensity of the thunderstorms we had. So if we have these more frequent, higher intensity precipitation events, you now need to see, is my BMP that I've designed for a system prior to a potential climate change episode adequate to address a climate change-induced system? Or do we need to derive new BMPs to address erosion sedimentation risk with this changing climate? There are several characteristics of shale gas that make it unique as a resource extraction footprint compared to others, like coal, strip mining, etc. And one that is classic is the rapid pace of that development. Until this year, you essentially had logarithmic growth almost. This year is the first year we saw a dip. All right, so this is as of this week's data, we saw a decline in production for the first time in the number of wells going in. So what we're thinking now is we'll probably see some steady development trend, maybe a spike every now and again, but we're probably at a fairly steady state number of wells going in annually for some time in the foreseeable future. And then one of the reasons, and the dominant reason really, why this decline occurred was because the price of gas plummeted. And that's because we got too good at extracting gas for a market that did not exist. Where the wells are going, about 93% of development is on private land. That's a problem in Pennsylvania because Pennsylvania's municipalities rule. There's no centralized land planning in Pennsylvania. So if you're going to control development, if you're going to try to enforce statewide restrictions, you've got to go about it via state law that affects the construction aspects. You can't centrally plan. In that area of development, we're seeing about half in core forests, about half in ag. And the areas that are being developed in ag, a lot of that will go back into some type of production following. The major hydrologic basins affected in the state are first the Susquehanna and then the Monongahela and Allegheny. All right, we're seeing more and more development in the Ohio, though, because of the prevalence of the wet gas down that part of the state. But the Susquehanna Basin by far is the largest affected. Very little in the Delaware River Basin, largely because of the risk to the water source or water users in this part of the state. And there's a lot of management planning going on now with the Delaware River Basin Commission. In Pennsylvania, recreation industry is paramount to the economy, and fishing and hunting are two of the biggest. There's a lot of concern in the Susquehanna River Basin with the Class A trout streams in these areas, and there's very little that's been done to monitor these so far because there isn't a lot of funding for it yet. But if you look at the prevalence of these Class A trout streams in relation to the development, there's a potential for these areas, which are typically headwater streams, a lot of them in core forest areas, to be negatively impacted by development if the BMPs fail. The SRBC, which is the organization that monitors water withdrawals within the Susquehanna River Basin, estimates that about 30 million gallons a day consumptive use will just be associated with the Marcellus formation alone. That does not include the Utica. This is about what a nuclear power plant uses in a day. And during the peak, we were looking at about 4.4 million gallons withdrawn per well development. Right now, that's about a third to a fifth of that value because the well development has really slowed down in the state. The other significant challenge that we're seeing to understanding shale gas development in Pennsylvania and its footprint across the state is its dispersed pattern. This makes it very hard to get an idea on the big picture effect that it'll have on Appalachia and the state. This dispersed pattern is a lot like wind. Pennsylvania's energy portfolio is a multifaceted portfolio now. Coal, natural gas, conventional, unconventional, wind, nuclear, geothermal. There's a wide variety of energy sources. Here you see an example of a freshwater holding pond used for a fracking operation. All right, this is a typical site now you see across Appalachia and Pennsylvania. The third major factor unique about shale gas extraction compared to the other resource extractions we've seen in the past is the degree of its effect on the landscape. And this is likely to have a lasting effect on the landscape, unlike other resource extraction periods we've seen in Pennsylvania's history. But it's important to recognize shale gas extraction is not equated to West Virginia's mountaintop removal or strip mining. It's not the conventional shallow gas development you see typically all across Appalachia, but it's not 1880 again. We're not going to clear cut Pennsylvania. It's not a derrick in every 3 feet. Certainly it's going to have an effect, and that effect is going to be dramatic. We know that already, but it's not going to be the 1880s. There are many processes that occur as a pad is being developed which affect that landscape and the resources on that landscape, from the clearing of the site initially to the initial construction of a flat surface. This may or may not turn into be a pad down the road. You just don't know unless you're with a company. Sometimes pads later on that become a well pad are first used as staging area for equipment. There's pad access roads that are developed. There's a lot of grading that occurs to level a site. Good example of that slope challenge we have. Here's an example of a pad with a well, or what's called a Christmas tree. This would be an example of one of those small transmission lines moving from a pad to a main federal line, a freshwater pond, and then this was an example of what a reclaimed pad looks like here. This is one of the few pictures you'll see of a reclaimed pad, because we're just not going to be reclaiming pads for a long time to come. Right? Along the edge of that pad, like any disturbance, you're going to see some migration of the pad because of wind throw. Because now you have a gap in the forest, it will behave like any other forested gap, and it'll respond to wind throw over time as tree death occurs and wind movement.
When you say you don't reclaim a pad for a long time, that's because it's continued use, or because it takes a long time to reclaim it naturally?
Oh, I'm going to get into that. Yep. It basically has to do with the cost of developing that pad and access to that pad down the road if you have to refrac. So if you have to refrac, you need that space. And that space is a lot of money. For every pad built, the Nature Conservancy did a study, and they estimated that about 12 hectares is disturbed. We did a study where we used national agricultural imagery from the USDA, and we found that for pads that were not reclaimed, which were about 1,081, the pad footprint was about 5.1 hectares. The disturbance associated with that pad was a median of about 2.2. But look at the max. We found one that was as large as 20.5 hectares. And this was one of the areas where you're starting to see larger and larger pad development at the cost of fewer pads, so less fragmentation on the landscape, more wells though on that pad. On areas that have been reclaimed, we actually found 202 pads that had been reclaimed, and this was back in 2007. The median pad size after reclamation was about 1/10 of a hectare. All right, the median with disturbance around it, so access road, transmission line, was about 0.4 hectares, and the max size left behind was 3.3.
Convert that to acres,
So let's see. You're looking at about 5 acres, or let's see, 2 hectares, 5 acres, right? So that, okay. Over 75% of the pads still have less than 3 wells per pad. That's a problem because you still have a lot of pads that could have infilling occurring. That's why the pads aren't being reclaimed. We are seeing a trend, though, in the last 2 years with larger pads being built with more wells on them. The total Marcellus build-out, the Nature Conservancy estimates, is going to be 6,000 to 15,000 pads with about 4 to 10 wells per pad. And this could be an area disturbed of about 180,000 hectares. Compared to the amount of abandoned strip mines we have in Pennsylvania, it's a far greater number. And that's just abandoned strip mines. That's not active strip mines. So from a landscape disturbance perspective, we're looking at something equally, if not more, significant than strip mining's history in Pennsylvania, which is a whole book in of itself. There's a distinct difference between how private lands and public lands are developed. On public lands, you see a lot of this. Here's your old forested road. All right, and you have a sister gas and water line right adjacent to it. The goal of this is to decrease fragmentation. Okay? On private lands is where we see the most new road building going into areas that they want to develop. So pipeline and road development, not pad development, seems to be the greater factor we're seeing that could disrupt the landscape down the road. And the character of this landscape prior to development, here's a typical Pennsylvania forest road, and this is a minor alteration to that road to allow gas trucks to access. All right? We're typically seeing these widen further now because the equipment's so large. They're finding that for long-term seasonal maintenance, they need a wider road base so they don't have the drainage problems they have with the encroachment on these narrow, older gas roads. So this would be an example of an older modification. The newer roads we're seeing are a bit wider than that. But this is going to have a different hydrologic characteristic. And if there's one thing you've noticed throughout these pictures, the shale gas roads are gray. And that's because a lot of times they're using limestone that they're bringing up from the Ridge and Valley province onto the plateau to cap the roads. And that limestone is going to have a higher pH. And the dust generated from that higher pH limestone is going to drift into the adjacent forest. And that can have an effect of essentially liming those soils. These Appalachian surface soils can have pHs as low as 3.3 to 4.2 in the surface soils. That will have a liming effect, and we're finding through research with Dave Mortensen in our group that it might have an effect on invasive species promotion.
Is that a
Yes.
consideration?
Yes. For the companies, you mean?
Yeah.
Yes. So one thing we were interested in looking at was the effect on development on Pennsylvania's core forests, because these are some of the last intact forested areas in the Appalachians. They're important areas for a lot of migratory species. Here you see a model of the core forest in Pennsylvania, which would be anywhere over 100 meters from a non-forested area. So it's essentially an interior forested area. And you see a model of where the well distribution or pad distribution is in Pennsylvania. And what we find is that, like the landscape analysis we did, about half of the development's in non-forested areas. In those forested areas, about 25% is in the core. Okay, the remainder is occurring in these areas that have some prior nearby disturbance, whether it's edge or an interior gap in that forested area. So 25% of the development has been occurring in these interior forest areas where you have a lot of these neotropical migrant species. So right now there's a lot of research going on looking at the effect of the development, whether it's sound or proximity to disturbance, in these areas where you have these core forest environments and these neotropicals. The impact that's been found so far on the avian community specifically with conventional, unconventional development is that we're seeing some relocation of species that have a high site preference, and we see a higher homogenization of species as they fill in that gap or edge habitat. We're finding evidence of hydrologic capture associated with development, and this is going to result in some areas of the landscape becoming wetter and some areas becoming drier. When I first got involved in the project, this was literally the first thing I did the day I was asked to become part of this research team, is I got our LiDAR data and I ran a wetness index model of an area where I knew there was a pad. And I said, wow, this could be really interesting, because what you see in this picture is a model showing areas of the landscape that potentially are wetter, which are blue, and areas of the landscape which potentially are drier, that are red. So one of our basic questions was can we use this information in the field to look at changes in soil moisture and soil carbon associated with development, changes in nutrient pools. There's a whole host of potential research projects here dealing with hydric soils, loss of wetlands, hydrologic capture. So this would be an example where you might have a flow path originally moving across this part of the landscape that no longer exists. We use this model in a couple of examples with private landowners. So the slope in this case is going towards the top of the screen. The wetness model here is showing an area with a seep across a property boundary line which runs right here. You have a stone wall running up this part of the property, and what the wetness model is showing is the existence of the previous seep and a documented potential for soil moisture movement and surface water movement along that stone wall, which was confirmed by the landowner. This outline shows where the pad's going to be developed, and the red dot is where the well is. This is an example where you can see the actual pad built right on the property line, and there's the old seep. Okay, there's a trailer right next to the pad. And then here you see the effect of surface flow that was rerouted from that stone wall now down the adjacency of the pad into the guy's barn on the other property. And he had to sandbag his barn to prevent the surface runoff from storms going into his barn. So this is not rocket science. This is something that soil scientists, geologists, hydrologists have been doing for decades, as long as the DEM has been around. The thing is getting companies to use this as a planning tool. That's valuable, because that could have stopped the lawsuit. We've also started to exploit the LiDAR data in Pennsylvania and essentially done a reverse flow accumulation or a reverse wetness index. And in this case, what we're doing is looking at the effect of hydrologic capture from the placement of infrastructure. And what you're seeing here is the white area shows areas of the landscape where water that would have flowed is no longer flowing because that structure was built. And what you see is that there are good pads and there are bad pads. All right? Some pads are going to have very little effect on the surface hydrology. And we know this. We've measured this in the field. Other pads are going to cause a problem. The question is, how big of a problem? What's downslope that moisture is no longer reaching? Is it a wetland that was depending upon that moisture? Right? Is there an endangered species? Is there a T&E species? So one of the questions we have now is how can we use this information to better look at wetland research, surface runoff research, amphibian migratory pathway research, or T&E species loss. How the infrastructure is going in on the landscape is dependent upon the geology and the surface characteristics. All right? This is really going to be dependent upon the land manager's perspective, right, the DCNR, the private landowner, who's thinking about their streams, their forests, the integrity of those communities. The gas companies, though, is thinking about the depth, the thickness, the integrity of that formation, its flatness, lack of faults, okay? What we have to do is figure out if we can synergize these two perspectives. And this is difficult to do because the changing economics and technology that the industry is experiencing just since 2003 is tremendous in what they're able to do now in Pennsylvania. What we can do now in Pennsylvania, you could not do in Texas during the peak of the boom there. And what we can do in Pennsylvania can do a lot to decrease landscape disturbance. The factors that are out of our control, gas pricing, drilling technology, water supply management technology, these are the things that companies have to think about because of the bottom line. And you may have the best idea in the world to help protect the landscape, but if it does not help the bottom line, it's probably not going to get done. There's some interesting aspects of this when you think of protection of environmental resources, all right? The DCNR has this policy of avoid, minimize, mitigate, and monitor, all right? Their success is largely in pre-lease planning, getting in there before any development occurs. The TNC, Nature Conservancy, is trying to work with companies to develop this design tool which will help guide design. That's difficult to do, but they're having some success with it. The Marcellus Coalition, which is represented by all the companies, has come out with their recommended practices, which is a collection of practices taken from the literature that are pre-existing. If we look at what Pennsylvania is doing, by law, you have a permitting process that largely is built on landscape disturbance and T&E species. This has really been good in some respects because we know a lot more about the wildlife species in Pennsylvania and their distribution, but because it's project focused, we don't have a bigger picture effect yet because we're looking at this pad and what's going to happen there and this pad and what's going to happen there. The bottom line when we're trying to reclaim a water holding pond like this 17 million gallon freshwater pond is that we know what we need to do. What we need to do to get it done right is change human behavior. I argue that we need no more research to know how to reclaim this site. We know how to do it. We have the money to do it. We just have to get the money to the landscape to do it. Pads, we now know, may have operational lives of decades instead of months or years, and this could significantly delay reclamation efforts. And the reason why these pads are going to be around is because they're expensive to build, it's hard to get a lease, those wells are going to be productive for quite a while, and those wells may need to be refracked. And if they need to be refracked, they need the space to get the equipment back on that pad. While the pads may not be at a point of reclamation, there's a lot of other infrastructure that is. The key thing is to think about everything I've talked about with the site, the soils, the landscape, slope, etc., because now you're looking at a case-by-case basis for reclamation. And here are some good examples. This is a site post-reclamation. Failure, success. Failure, right? What happened here was they got done in November, seeded the site, and you only have the south aspect here that took. You don't have the 70% cover, but a year later, you're good. Are you going to crack down on this company? That's a tough case to argue because it's not necessarily their fault that the season did not allow germination. You know, in November you can get some success. It's tricky, but you can. But if you go in and you start playing hardball with the companies and start throwing down fines, the fines are so low, why pay them maybe? Now, I have yet to see a company not do a best effort to get this done right. And if you go back and look at the site today, it's pretty good. It's not great, but it's pretty good. This is the poster child in Pennsylvania. This was forest before it was this. Okay, the landowner here invested a lot of money to plant these trees, and each tree is hand dug into the pad's former area. So this was a high wall, and all this soil was put back, and a tractor, a D6, I think it was, ran back and forth across this site to compact it. Is this reclamation effective in achieving a function similar to what was there before? And does it matter that it does not? This is private land. This person can do what they want. Is that adequate for ecosystem protection in some of these areas where we have these less vestiges of core area? Pipeline soil analysis in this case, all right? This is the soil left over when the pipeline was built. Soil pH, not too bad, all right? Pretty low nutrients. What they're recommending is that you apply a high amount of nutrients, in this case over 3 miles of pipeline. For every acre, you should apply 12,000 pounds per acre of lime to achieve a nutrient success for germination of perennial cover to meet the 70% cover requirements for the DEP. That's a lot of effort. That's a lot of money. Is there a better way to do this? We know if you start liming these soils that you're going to have a risk of promoting invasive species. This is the researcher I was telling you about before who did some of this work looking at the risk of these liming of these soils that are traditionally low pH. If we start looking at the physical effects, here's some interesting results. This is a table coming from the USDA NRCS Urban Soil Planning Manual. And this shows for different soil textures what would be an ideal mass of soil per volume or bulk density, one that might limit root growth and one that outright restricts root growth. And for the soils that we're going to be looking at in Pennsylvania, we're looking in this area. So anything around 1.55 we're going to start worrying about. Now we have a tool we can go into a site pre or post reclamation, make some measurements, and know if we're going to have a problem down the road. This is powerful if you're setting up a lease. You can actually put numbers in your lease now that tells that company if you don't achieve this post reclamation, it's not a successful reclamation. You have to do something about it. We went back to the historical gas development that was going on in the 1930s up by the Allegheny National Forest, and we looked at 12 gas pads and their associated native condition. And we went back into the aerial imagery and tried to look for any disturbance since that area was built. This was kind of hard to do because we didn't have aerial photography for every single year. But for what we know for these sites, for the most part, there was no disturbance. And we looked at the pad composition that was used or left behind when these sites were built. And what we found is if we look at the surface bulk densities, we do see a significant difference between the gas pad and the forest in the bulk density. And if we look at the subsurface bulk density down to 20 centimeters, and this is typically the area you're going to look for root restrictions, we see a significant difference. But the important thing is for these soils, you're not meeting the root restrictive barrier. These are all non-limiting bulk densities for producing trees. So for these sites that were put in the 1930s in the manner they were, which was literally just mounding up about a foot of soil for this small gas pad like the size of this area of chairs, today you don't have a bulk density problem in those soils that would limit tree growth. In fact, there's a lot of trees growing in these areas. If you go to a pipeline, just put in and measure that a couple of months after it was put in, here we have the surface bulk density in 5 centimeters, 10 centimeters, 15, and 20, pipeline in the forest, and the significance value. We see a significant difference across all values. We see root restrictive differences at 10 to 20 centimeters on the pipeline. And these are high. You know, if you're in a droughty condition, you're even going to have a problem with perennials in some of these cases. So what have we learned from Pennsylvania? Well, compared to past resource extraction disturbance, shale gas is going to have a unique footprint. Okay. Secondly, that footprint is exhibiting a very rapid and extensive and dispersed pattern. And this is very hard for land managers and regulators to deal with. You have an incredibly complex mix of public and private land issues. And at the end of the day, this is really a private lands issue. Because all the sites I've shown you, only 2 of these sites are private lands that we're working with. Everything else is state land. We're seeing a pretty substantial threat to these core forest areas, which again are some of the last vestiges of these areas left in the Appalachians. And there's an invasive species risk in these areas too, with species becoming predominant that weren't. We know a lot about reclamation. We know a lot about how to fix these areas and make them better. We know about the risks to going into these areas now. The bottom line is to be successful at the end of the day at addressing this problem, what we have to do is change human behavior. It's that simple. It really is. The challenge, though, is the economics behind this situation are not in our control. What we have realized is this is an amazing opportunity to educate a lot of people about ecosystems. And that's been a great thing for Pennsylvania because this area being developed is a documented food desert by the USDA. That means there's no food production within a certain distance of your house. There's grocery stores that have closed during the boom. Okay? These have some of the toughest education problems in the state of Pennsylvania is in this area of the state. You look at any town in this area where the gas development is occurring, and this was a boom town for 2 other extraction periods in the history. You know, Jamestown alone has experienced significant economic problems in Pennsylvania. It was a logging town that was started originally. It was one of the keystone towns in Pennsylvania. All right? And they're crashing again. So the money is not all staying in PA. what we've done to try to educate Pennsylvania citizens some more, and now others in Appalachia, has developed this electronic field guide which addresses a lot of these terrestrial concerns in depth. If you have any questions about what I've talked about, there's probably some answers in here. I would be happy to address them. Thank you.
I had a question. You were talking about the gas pads. I know that they can take up the gas for a long time, so it can last, into the dozens of years, possibly. And I know we talked about earlier, a lot of these companies, because it's kind of the boom and bust, there's so many here, and then a lot of them will be gone, maybe in 10 years, they'll go to business, whatever. So what happens to the pads that are owned by the companies that go out of business? Are they then bought, and then whose responsibility is it to do the reclamation at that point?
So the sites are bonded. So bonding is a solution to that problem. So there's a lot of sites in Pennsylvania. You go to DEP database and you'll see there's at least 300,000 gas wells in Pennsylvania. There's probably 100,000 holes in the ground. We don't even know what they are. They're just not documented, right? In those cases, like with a lot of the acid mine drainage problems, there's no money to fix that problem because there was no money set down ahead of time that if they didn't come back and fix that, they weren't going to get their money back. That's what a bond does. And so a lot of these sites are bonded. So as I understand it, even if the companies trade hands, there's still that bonding that has to be laid down. That may be wrong, but I'm pretty certain that's what I've heard. So I know if you're the company that hasn't traded hands, there's definitely bonding down for the reclamation.
So one environmental effect that I didn't hear you talk about was contamination of groundwater, and how prevalent is that? I know there's a lot of hype about it now, but how many cases we've seen?
So I'm not a groundwater hydrologist, but early on, the problems that we had in Pennsylvania were because of unlined wells up in the northeastern part of the state that were affected by shallow methane migration. So you've got multiple lithologies as you drill down through the flatbeds of Pennsylvania. There's shallow gas trapped up high, and when the drilling occurred, that methane was allowed to migrate, and because Pennsylvania has some pretty lax casing laws for its wells, that contaminated drinking water. Now what the companies do is they will go around and they will test everyone's water before they drill, and they will have a record of that water test. I was under the assumption they give that test to the homeowners, but I learned tonight that not all the homeowners are getting them. But they do this. I've had friends who've shown up and company asks, can we test your water? And they'll take that water test. Then if there's a problem later on, the company can back and say, well, you didn't have that water problem before, that's our fault, or, well, no, you had methane in your water prior. Now, I do know a lot of companies will notify the homeowner if they do find a problem, so maybe the ones that aren't are the ones that don't have problems. But if you have a methane problem, I'm almost certain you'll find out before any drilling occurs, just so the company will protect itself. As far as I know, and this is what I've heard at numerous conferences from state, federal, and gas companies, is there isn't yet, and I know there's a couple of cases now being examined where there's a documented case of groundwater contamination from fracking in the United States.
Is there a way of designing pads so they're less disruptive as they're sitting on, they're still active? I would assume, the current pad design is based on practicality of something that performs a function for drilling as opposed to surface disruption. You might be able to get something that would do both.
So what we're seeing in the last couple of years is some really innovative ideas that we're just starting to explore. A couple of companies now will bring in external materials, manufactured materials, essentially padding, so they don't have to disturb as much subsoil. Because remember what happened when the economy collapsed as well as prices of gas went through the roof. And like every time you're hauling rock, or every time you're hauling water, or every time you're hauling stone, that pad gets more and more and more expensive to build. And so if they can use this material, pick it up when they're done, move to the other pad, there's less moving of the soil they're going to have to do after the fact. So that's one thing we've seen a lot of. The frack water, they actually have evaporator units they've designed on pad to get rid of the water to produce solids so they can truck the solids off the site. So they are incredibly innovative at solving problems to save money. One of the big solutions to trucking water has been to build pipelines, right? So there's a mixed blessing. You saw what the pipelines can do. But if I had a kid up in that area and I'm looking at truck trips and how fast some of those trucks go, And I'm thinking, how many trucks might that one pipeline replace? Well, I can give you an idea. One pipeline that went in north of Waterville replaced, I believe it was 50,000 truck trips for the development of that gas field area, and it paid for itself in 6 months. And not one kid was hit by a water truck. So it's a real mixed.
Following up on that point that you're making, is the tendency then to do all this stuff by transporting stuff by pipelines, bringing in the fresh water, and how about getting rid of all the bad water that comes from that must be taken out by trucks, or is there a pipeline for that as well?
I have not seen firsthand, so that would be flowback water, water comes out. That water is most often recycled. It's put in a tanker, and that tanker's carried to another well.
There's still a lot of tanker transport and stuff like
For the flowback water, yes. So somewhere around 3 to 15% of the water comes back out of the well as flowback water, and that water is highly contaminated, cannot be discharged in a municipal treatment plant anymore. They were doing that originally. That water...
That isn't sent to Ohio to be pumped onto a saline aquifer down at a great depth.
If they can use that as water elsewhere, they'll do that first, because they got to truck it all the way to Ohio. And I have not kept up with the Youngstown problems. There was some seismic problems dealing with injection wells in Ohio from water from Pennsylvania. So I've not kept up with what's happening with that now, but I do know that if they can reuse that water around that site, it's far cheaper to do that than truck it out. They're looking at barging it down the Ohio River. I do know, I heard that the other day.
Yeah, I think they've stopped trucking it to Ohio for reinjection because of the problem with induced seismicity.
You mentioned earth movements as a potential risk of these pads and these scars in the landscape, but I didn't see any pictures of actual events that occurred in a disturbed environment. Are you seeing that? And then sort of like a related aspect is, do you think the greater risk is in these punctuated high disturbance earth movement events, or do you think it's more diffusive kind of fine sediment and particulate transport to and through the ecosystem as a result of the disturbance?
Yes. You have chronic bleeding of soil, and that varies by site, and it varies by company. Some companies, I can say, I've not seen any evidence of any material moving off site. It's amazing how good they are. Others aren't as good at that. All of them have to follow stormwater and erosion control plans. But the problem in the last couple of years that has coincided with the boom has been the types of storms we've been getting and the time of year that the operations have gone in. You got to remember, when they came into Pennsylvania originally, they were not used to this type of development and this type of climate. Thaws alone are tremendous erosion and sedimentation events. And the one we just had certainly caused problems that we saw in a couple of places. Is there anything you can do about that other than shut them down during those periods? That's your only alternative. But even if you shut them down, how's that going to be effective to try even predict that thaw environment? You basically have to say, once November comes, you're not working until post-spring, once that soil dries out. DEP recommends in Pennsylvania that the soil not be worked if you can take a sample in your hand and form a ball. How many months of the year could you work soil in Connecticut with that rule? It's the same number in Pennsylvania, maybe 2. Right? So you're going to give them a 2-month window to work? So we are seeing chronic problems. 99% of those are human behavior. 1% are those punctuated periods of disequilibrium thrown at us by Mother Nature, when you just happen to have a lot of landscape in a condition that you just don't want a big storm event sitting over. You just hope that that doesn't occur when one of those sites is open like that. Now, there are monitoring stations being put in along numerous headwater and larger tributary environments along the plateau. These are being put in the Susquehanna Basin specifically by the SRBC. And they are measuring conductivity. I think they're doing some type of sedimentation measurement too. I don't know if it's a Sichi disk type of measurement or something, but they can measure events from upstream and try to clue in on whether there's been some type of activity from shale gas development in that area that's posed a problem. The biggest problem we have is just maintenance. Silt socks not being cleaned out, the stormwater basins not being cleaned out. the BMP not put in right. So what you need is this better instruction, I think, and then some monitoring, maybe with a little more teeth. You know, you can drill a hole 5,000 feet this way, 3,000 to 9,000 feet that way, right? I think there's enough technology and smarts to do a better job at the surface. So.
You had a slide that compared the amount of water used to a nuclear power plant.
Yes.
And I was wondering if you had an equivalent in energy production.
Off the top of my head, no. But Jim Rickendorfer with the SRBC might be the guy to ask that question of. He might be able to do that for you.
The water used, though, is just during the time of fracking and so forth, right? I mean, that's not going to continue for the life of the pad.
Right.
But I'm just talking about the magnitude of water for the amount of energy that's
Right.
Being produced.
In the lifetime.
It's a total sum.
You know, I guess one argument I could see a gas company using in Pennsylvania is, well, given the prevalence of water in the state, how big of an issue is it?
Right.
That's one I've heard a lot of. But I know, you know, SRBC just recently instituted this low flow policy in Pennsylvania across all users, where if flows and streams reach a certain level, you can't withdraw anymore, which is great because there is evidence, there's been some cases where literally water was being withdrawn from a stream and the stream went dry. It's pretty amazing to see happen. But, you know, if you suck enough water out of the stream can't keep filling up that area and it will go dry. That's pretty wild. One area that's also concerning us is the installation of water withdrawal wells on top of the plateau. You know, remember you only got a thin layer of soil up there before you hit bedrock, and those thin soils have small wetlands. If you start pulling water from that plateau, your cone of depression is going to start dropping, and those wetlands may not be wet anymore. Now, there aren't any of those permitted, I believe, yet in the areas that we're worried about. I think SRBC's denied all of them. But I've stood next to one that was installed. It's just not operating. So.
What is the main source of the water then, if you average it out for the whole area?
Streams and municipalities.
What?
Streams and municipalities. Yep.
Which takes all that other stuff into consideration.
Like?
The desiccation of changing the groundwater table into critical areas.
Well, in the Susquehanna River Basin, that's heavily regulated by the SRBC so that you don't see that effect. That's why they are quantifying the water withdrawals across all users, and that's how they argue they came up with that low flow policy so that you cannot have that effect that you're worried about, because if the streams get to that point, we don't care how they got there, we're shutting you all off. Go ahead.
Can you expand on what you mean by municipalities? Is it municipalities' groundwater?
So if I owned a town, so if, you know, there's townships that have their own water supply, I could sell water to a gas company.
Okay, and is that water, a lot of it treated? You know,
That's fresh water, yeah. It might, some of it also can be water just pulled from the source, the stream that they own or the well field.
One of the issues you pointed to was the development of pipelines in an unplanned way across the landscape, especially on private land. And I wonder if you could maybe speak a little bit more about different solutions there might be to addressing that lack of planning that we do see on the state lands, but not on the private lands.
So the lack of planning is more on the private land. It's not the state. On the state land, it's literally a debate that goes on in the room, and sometimes that debate leaves the room and it's between Houston and Pennsylvania's government. On private land, though, it depends on two things. Do you own your mineral rights? If you don't own your mineral rights, they're called severed rights, okay? And if you don't own the rights, you don't have a lot of say to what happens. If you do own the mineral rights, you have a lot more power in your lease negotiation. And in that case, you can tell the company, we really don't want the pipeline going across this area. There have been some instances where some people have tried to stop a pipeline because they're the one property that has not agreed to let the pipeline cross, and then those cases go up through the Pennsylvania court system. But there's really very little large-scale planning that goes into where the pipeline's going to go. it has the least environmental impact. A lot of it has to do with the economics of getting the pipeline there. And the companies will work to avoid areas they have to avoid. You know, if it's regulated, the wetland crews will start walking. Those wetlands will be documented. If there's a taking, there'll be a reclamation for that wetland somewhere else, a mitigation. And they are by law required to look for certain species. You know, there's an act in Pennsylvania that requires them to do certain surveys for wildlife in order to avoid those habitats, and they will avoid those. But there are limits to what can be done because of Pennsylvania's Commonwealth law and the lack of regional planning in a lot of these areas being developed. And the fact that, you know, the resources the companies have are tremendous. And you know, I got to qualify this. I don't mind working with the companies. A lot of my friends that I used to work with before they worked for the companies worked for the state. And it's the same person. It's just the goals of what they're trying to do differ because of the economics of that company. And I'm not trying to justify gas in this sense that it's the best thing that ever happened to Pennsylvania. But no way are you ever going to negotiate something and then just have a one-sided win in anything you do in life. That's pretty rare. And if you're doing that, odds are it's going to burn you down the end anyway because you're just dominating the situation too much and you're not compromising. The success that I've seen comes in Pennsylvania has come because of compromise. And really, literally, at the end of the day, it's the gas companies that have really come around in a lot of cases. Not all. There's some areas that are absolutely gorgeous that have been developed, and it stinks. But I had a guy, and we were talking about this at lunch today. He has a son in the military in the Middle East, and he has a gas well. And he does not like the fact that his son's in the Middle East fighting a war, which he said, not me, is largely because of oil. But he has a gas well in his yard, so his son's kid may not have to do that in the future. It's a complicated situation that touches at the very core of what an ethic or a value is for a land or a human condition. You know, I've had men who are 70-year-olds stand in front of me and cry because they realized they didn't own the mineral rights and the area they hunted with their grandfather when they were 6 years old is gone. You know, that's why I do this. It's hard to do this because you see every day what is going on, but you also have an incredible chance to do something as a professor to make a difference. And that's, in this situation, that's really why I do this job. But you've got to be careful. If you go in there flaming guns, no one's going to listen. And, you know, how we can address the private lands issue, if we can figure that out in Pennsylvania with this, you'll have done a tremendous thing to help Pennsylvania, because that's our biggest problem.
Okay. If it's a quick one.
Yeah, it's a follow-up question based on what you said. I know it's a difficult task to address the private land management, but how do you envision it to be managed? It should be a new institution, a coalition between the private sector and the state authorities?
What would I do?
Yeah,
Yeah, I like the idea of conservancies. You know, I think there should be a fund created from the gas money in Pennsylvania used to buy lands in reserve in conjunction with the gas companies where you're going to sacrifice some areas, right, that are going to be developed, other areas you're not going to touch. I would stop all development on state land because those are the last areas of intact forests we have that are managed. And then start buying up the private land tracts, like the Mellon Estate down south, you know, that protecting that. You know, we have some large tracts left in Pennsylvania that are just gorgeous. That's what I would do. Because you can't take it politically. That's not going to help anyone. That's just going to cause more civil strife, and we've got enough of that in this society now. You got to remunerate someone somehow, and there's plenty of money to do that.
Okay, thanks very much, Pat.
Thanks.